This is a production of Cornell University.
Okay. Hi, my name is Nick Vanderwall. I'm the director of the Einaudi Center, and I'd like to welcome you all here today, and particularly welcome Dr. Harry Kuiper to Cornell. This talk has a sort of complicated lineage, so let me describe it very briefly. It's part of the project Getting to Know Europe, Ithaca and the European Union, which the Einaudi Center has been doing in collaboration with the Institute of European Studies, and it is supported by a grant from the European Commission to Cornell. I want to thank Sid Van Morgan and David Greenwood of the Institute of European Studies for their work on this and helping to get this very, very useful grant to Cornell. It's allowed us to have a kind of European theme to a more long-standing series, which is our Foreign Policy Distinguished Speaker Series, which is part of the Foreign Policy Initiative, which the Einaudi Center has been undertaking for about 2 years now. This Foreign Policy Initiative dates back to our sense that we needed to promote foreign policy issues on Cornell and have a very broader discussion of foreign policy issues and a broader understanding of foreign policy, which is why we have someone speaking today about GMO crops and presenting it, as a foreign policy issue rather than as a purely technical issue or a purely European issues. The Foreign Policy Initiative has allowed us to bring people to campus in a variety of ways. We're teaching an undergraduate course on current events as part of the initiative, and we've had a kind of faculty network of about 30 faculty members who are part of this network. Let me also say that I'd like to thank both the Einaudi family and Luigi Einaudi in particular for a grant for the Foreign Policy Initiative and a grant from the Kessler family for the initiative this coming year. As part of this EU speaker series, when we started it, we wanted to do 4 things. We wanted to have a focus on EU-US relations, and last spring we had Joschka Fischer as the Bartels Fellow for the year to address these issues, specifically of US-European relations. We wanted to talk about the latest WTO trade round, and in that context, let me plug the interesting talk we're having next week by Dr. Carlo Trojan, who's been the EU ambassador to the WTO negotiations, and who will speak here on campus on October 23rd in this particular room, also at 4:30, so exactly a week from today, and I encourage all of you to come to that. We also wanted to talk and to focus on the expansion of Europe and EU enlargement issues, and let me plug our first debate. We'd like to have regular debates in the Foreign Policy Initiative, and the first one will be on November 12th. We'll have a debate between Soner Gapatier and who's the director of the Turkish research program at the Washington Institute for Near East Policies, and he'll have a debate with Professor Laure Delcourt, who is a senior professor at the Institute of Political Science in Paris, on whether basically EU enlargement and the accession of Turkey to the EU. Let me also very much encourage you all to come to that on November 12th. Today, we're addressing the 4th topic that we had set out at the beginning of this process, and that is on the issue of genetically modified crops and food safety issues, and the difference in the way these are perceived in Europe and in the US. So it's my great pleasure to introduce probably the most perfect person to talk about these issues from across the proverbial pond, and that is Dr. Harry Kuiper, who is a senior scientist at the for Food Safety at Wageningen University in the Netherlands. Dr. Kuiper has been working on food risk assessment and GMO issues for well over 2 decades. He is the chairman of the scientific panel on genetically modified organisms of the European Food Safety Authority and a member of the Dutch Union of Toxicologists. He's a leader of various national and EU finance projects concerning food safety. Dr. Kuiper is an absolutely prolific writer who has co-authored well over 200 journal proceedings, scientific reports, and chapters. He's worked with the World Health Organization, the Food and Agriculture Organization, as well as the EU. Finally, after getting his master's degree in food science from the University of Wageningen, he got his PhD in biochemistry from the State University of Groningen in 1976 and has done postdoctoral work at the University of Rome. Please join me in giving a warm Cornell welcome to Dr. Harry Kuiper.
Thank you very much, Nick, for this nice introduction. You were stealing my time on mentioning my curriculum vitae. I really feel honored with this invitation to come to you and speak about an issue as phrased here on genetically modified crops and how Europe or the European citizen and scientists are dealing with this issue in Europe, which I think is a bit different from attitudes in other parts of the world, like in the US. And although the title is Getting to Know Europe, I would like to reverse it, and I would like to get a better idea on what is ongoing and your ideas and thoughts about crops in the US. So I hope there is sufficient time for discussion. Now, I have made a very stupid decision before coming, and that was just to be here today and tomorrow and leave immediately again. I had a fantastic visit this morning at your campus, which is fantastic, which is wonderful. I visited one of your libraries. And listening to Nick on the agenda of talks for next week and after, it would have been nice to stay a bit longer here in this place. But unfortunately, that is how life goes. What I would like to do in my talk is give you an overview of the regulations regarding food safety and environmental issues of genetically modified crops in Europe, the regulatory framework, tell you something on the main topics on food and environmental safety issues, and I hope to continue that discussion tomorrow morning at the Plant Breeding Institute. And I'd like to finish with some remarks on public attitude in Europe, which are measured every 2 years. And there is a fairly good survey on the results, and try to find out also in the discussion with you what are commonalities with respect to public attitude and how we should proceed in this area. My personal opinion on GMOs is not very different from the one I had 5 years ago, that the situation is still very, very difficult when it comes to market release of these crops. But I'll come back to that later. Now, as we all know, genetically modified crops is not just the science around in terms of modification of plants or organisms in general. The discussion is much broader. We are dealing here with the ability of a technology, the recombinant technology, to cross species barriers. And that is something which is difficult to explain to a large public. It's easy, fairly easy with scientists, but with a large public it's difficult to explain, in particular with respect to what about effects of these phenomena. Of course, impact on the environment, on biodiversity is an issue. Like What about long-term effects on human health, human or animal health? What do we know on long-term effects of our normal food supply? I must say very little. There are very few traditional foods ever being tested chronically for health impact. Maybe irradiated food is a category of foods which have been tested systematically for long-term long-term effects, but not any other types of food. Test systems, the possibility that if somebody does not want to have GM foods on their plate, what is the guarantee for a GM-free diet? And last but not least, what is the contribution of the technology in terms of sustainable agriculture? And who are the stakeholders and the interests? It cannot be only the big industries, the big chemical industries. There are small farmers around the world who could profit of the technology. So it's a whole array of discussion issues which should be taken into account when you discuss these things. Now I am a simple food toxicologist, so I will concentrate on the scientific aspects, but we should not forget that the discussion is much broader. Now you probably are familiar with the dramatic increase in cultivation of genetically modified crops, mainly in the US and Canada and Argentina. But countries or continents like India and China are really in the lift in terms of cultivation of crops. And what is out in the field there, it's primarily modification to improve the agronomic characteristics of crops, like insect resistance or tolerance against herbicides, or combinations of these traits. This is what I would call the first generation of crops out in the field. However, there is a development which is ongoing, and there are very interesting examples, as I show here on this slide, with respect to the development of foods which have health nutritional beneficial properties. And I've just listed here a few. And I think this is the real future of biotechnology applied in the food area, to modify crops with certain compounds which may be of beneficial or nutritional impact. However, there is one warning from my side, that is that from many bioactive compounds which may have a beneficial effect, the scientific basis is still very, very weak. We are working in my lab on a number of compounds, so-called antioxidant compounds, which, if you look at epidemiology, show positive effects in prevention of heart diseases and other chronic diseases. But it depends on the data you're trying to gather. But some of these compounds, an antioxidant may become a pro-oxidant and may become highly toxic. So this is not an easy area to work on. And it will take time for developers to come up with the real compounds which have beneficial effects. I don't think there are any miracle compounds in this area. Now, talking about the European situation in terms of risk regulation of genetically modified organisms, this is Europe. It is expanding all the time. And this is the Europe, that's the state of the art today. We are dealing here with many countries, old countries and newcomers, but the point here is that every member state has its own regulatory system. Moreover, the public attitude and the culture is very different in very many countries, and that is a problem for the European Commission to face. Now, we have a history in Europe which has resulted in the fact that the public trust in governments, in particular in what we call Brussels, is very low. And we have had a number of accidents or incidents, if you like it. BSE, dioxins, bird pest, and go on. The impact of GM crops on what I said, the environment and long-term effects. So this has really affected the public at large into a fairly negative attitude. Now, the European Commission has tried to reverse the situation. there has been a systematic approach in the area of food safety assessment by establishing what we call a European white paper on food safety and a general food law, which is really the new framework for food safety issues, not only GMOs, but contaminants, etc. It sets the scene what kind of information should be looked at before decisions are going to be made. And last but not least, the establishment of the European Food Safety Authority in 2002. So this year, 2007, we have the 5th anniversary of the European Food Safety Authority. That's at the end of this month. There is a big event in Brussels. Now, the main reason to establish the European Food Safety Authority was the fact that there needed to be more clarity in who does this scientific assessment of food safety problems. In previous days, there was always a mix-up of risk managers, commission members, together with some scientific institutions to come to some kind of assessment, but there was not much of transparency in that area. And the main task, and I come back to that later, of the European Food Safety Authority is risk assessment. It's the scientific risk assessment of emerging and ongoing problems. Now, there are, with respect to GMOs in Europe, there are two main frameworks for the assessment. One is the environmental regulation, the Directive 2001/18, which regulates the release of GMOs in the environment. And the regulation number 1829 regulates the release of foods and feeds on the market. There is a definition which is, I think, important, what we define as genetically modified organisms. And I read it because I'll come back to that later in the discussion. It's an organism, with the exception of human beings, in which the genetic material has been altered in a way that does not occur naturally by mating and or natural recombination. Now, in the scientific area, there is a discussion on this principle, because crossing of genes from one to the other species happens, but there are species barriers to take into account, and therefore the emphasis on not natural crossing. Now, the establishment of the environmental directive in 2001/18 has solved a number of problems. And I think the most important one is the establishment of a transparent methodology for the assessment. I come back to that later. And secondly, before GMOs are introduced in the environment, it should follow a step-by-step procedure in terms of upscaling of release of genetically modified organisms. I think this is an important issue, maybe not for the first generation of crops which in the fields, which are relatively small in terms of changes. But when we enter the area of substantial modifications of crops by putting in whole gene cassettes, then I think it's very important that with respect to environmental release, we do follow some kind of upscaling procedure. Another important thing of the directive is the monitoring. First of all, the monitoring is meant to confirm what we assume in terms of risk assessment. We should realize that any risk assessment bears a number of uncertainties. There are always extrapolations to be made in terms of scaling, in terms of timing, also in terms of species to be affected. So there is a certain extent of uncertainty which should be taken account. And further on, the occurrence of effects which have not been anticipated could be picked up by monitoring. So monitoring for the environment has become obligatory in the new directive. Now, the food regulation and feed regulation is very clear in the fact that if something would be applied by a manufacturer for market release, then Europe does not only look at, for instance, food, but also at feed. So a crop can never be only admitted as food or as feed. We look at both aspects. We have learned a lot from the US. You may remember the Starling case, which initially was approved by FDA for feed application. This is this genetically modified corn, BT corn, which was some years ago just admitted for feed. And then after 3 months, it turned out to be a contaminant in the human food chain as well. Well, Europe wants to prevent this situation, having learned from your experience. The regulation does not deal with animals which have been fed with genetically modified feed, although some of the NGOs like Greenpeace have brought up this case now in Europe, that also these products should be labeled. Now the GMO panel, which I am chairing, has recently issued a statement on this issue, and by saying, well, there is no indication for transfer of genetic material which contains genetically modified elements. Even if so, then we do not think there is any health risk involved. So we really discourage the labeling of products from animals fed with GM feeds. Also in the regulation on food, post-market monitoring may be needed. And what is very important is methods for detection. There is a center in Europe, in Italy, the Community Reference Laboratory in ISPRA, which really should take care of the quality of the detection methods. Labeling is covered in the 1829, that clear labeling is required only in case of advantageous presence or unavoidable presence of minute traces. Then we have some threshold levels, but in principle labeling is required. I skip every now and then a slide because I really want to concentrate on the main issues and have a discussion. Now this is one of, I think, the slides which shows you how complex the regulatory framework in Europe is. Now this is an example of a dossier which has been submitted for food and feed release on the market. Now the dossier is evaluated by EFSA, by the GMO panel, and I'll come back to that later. A scientific opinion on that dossier goes to the Commission, and member states can react on it. So there is a consultation period with member states on the dossier, which is quite lengthy because many member states have their comments and their criticism on an application. So then the panel has to look at all these comments and see whether they are valid, yes or no. Once an opinion has been reached by the panel, then it goes to the risk management phase. The European Commission should make a decision. And there is a public consultation phase, and before the European Commission makes a decision, it consults member states. And in practice, a process to go from here to here, that may take, I would say on the average 1 to 1.5 years. But in this phase where the European Commission would come up with a proposal for release of the GMO, in consultation with member states, in practice, almost all the dossiers up to now have been blocked in this phase. So it's in the risk management phase where member states have their say by voting. And there is a system of preferred voting that bigger countries have more votes in that committee than other countries. And up till now, for most of the applications, there has neither been reached a majority pro or a minority against a dossier. So this is really the process where things get blocked, and I think that is an issue where the risk management should really think about it. Now this is the 2001-18 procedure, which is quite similar to the one I showed you, so I'm not going into details here. It is the EFSA who does the scientific assessment and the positive advice, which, as I said, may take time, may take 1 year, 1.5, in some cases even 2 years, in order to get a complete dossier of an applicant. In case data are not sufficient, we go back to the applicant, and the applicant can submit new data. And then at a certain point, after our opinion, it goes to the European Commission. And as I told you, in that phase, things may be blocked. It's very difficult to resolve this issue. The European Commission formally can overrule member states' objections. And they can make their own decision, which has been done in 2 cases of dossiers. But personally, I do not think you can do that all the time, overrule objections of member states. Now, what about the EFSA? The EFSA is, as I said, is an agency independent from the European Commission, and the main task is to deliver advice and risk assessment on issues related to food safety. The structure is a director and management board advisory for and 9 scientific panels in different areas. I come back to that later. Now, its main mission is the risk assessment, to provide, as I said, scientific advice and risk communication. When an opinion of the EFSA is released, that needs some layman language as well in terms of consequences on impact. So we work on that as well. But I'd like to underline the fact that EFSA is not involved in the decision-making phase of an application. So EFSA is outside the risk management activities. And that is also the main reason that the EFSA, although born in Brussels, has moved now to Italy, to Parma, to also physically separate risk assessment from risk management, which from a theoretical point of view is a good thing. But as you all know, there needs to be a communication between risk assessors and risk managers. So in terms of communication, of effective communication, it is a challenge, this physical separation. Another important aspect of the EFSA task is that, well, apart from the applications, is to answer questions of the Commission and of the European Parliament and of member states, and also of NGOs, which in practice acts through member states or members of the European Parliament. So we get a lot of questions on issues related to GMOs. And more importantly, the EFSA is also, the panels can take their own initiative in developing new guidance in certain areas, which is called self-tasking. Now, this is the list of the panels of EFSA in the area of food safety issues: contaminants, additives, dietary products, biological hazards, animal health, plant protection, plant health, and the genetically modified organisms. Now, the structure of the panel is we have 21 members from Europe with different backgrounds, either specialists in environmental toxicology or in molecular biology or in food and feed safety aspects. And we have a number of working groups under the GMO panel who works on the various issues. Now, up till now, we have issued a number of guidance documents on plants and foods and feeds. That has taken much of our time. I consider this really, that's our Bible for the risk assessment. We have issued guidance on post-market environmental monitoring, on genetically modified microorganisms and their products, on renewal of existing products and stacked genes. And all these guidance could only be established upon an extensive consultation with all kinds of experts. To give you an example, on the guidance document for risk assessment of plants, we had over 400 reactions of member states and NGOs, which you have to take into consideration one by one before you come to a final version. So this is really time consuming. We have issued a number of other opinions, like on, which is a hot potato, the presence of antibiotic marker genes in plants. And we are working on a number of other issues, like new approaches to test for potential allergenicity of crops, and also on the nutritional assessment of plants and the role of animal feeding trials. I'll come back to that a bit later. and so on. So there is an extensive task of the panel on trying to develop new methods and methodologies for the assessment. An important one is the statistical, an improvement in statistical approaches. We have noticed that applicants use very different statistical methods to interpret their results, which is, from a scientific point of view, in many cases okay, but a better harmonization and streamlining in that area is important. Well, this is the guidance document. Now, I'd like to spend the next 5 minutes on the general framework for the risk assessment, which, in case of Europe, is not different from what is applied in other parts of the world, in the US, in Canada, in New Zealand and Australia. And it is based on general consensus by international organizations like OECD, FAO, and Codex have taken a leading role, and also some European institutions. So there is a very broad general support in the area of food and feed safety assessment. For the environment, it's a bit different. There's not much structural design documents in that area which have that many details as the European Food Safety Authority. But for food, there's a fairly good consensus in that area. Codex has taken the lead in this area in designing guidelines for the food safety assessment. Now, the essential departure point for food safety assessment is a simple one. The underlying assumption is that traditional foods are safe to eat, whatever the science is there. There is not much science. It's more empirism and history of use. I mean, you have been fed by your parents as a child and thinking that foods are safe, but we know that foods are loaded with toxins. So you can never say a food is absolutely safe, like you could say for a chemical. So it's a relative concept, safety. And we rely on history, on experience, on preparation of foods. That is what is the basic assumption of the assessment of crops. It's traditional foods as a reference, as a standard point. And what is done then is try to identify potential differences between your GM crop and your non-modified traditional crop. And if there are any differences, you should assess those differences. So it is a relative assessment of safety. Now, or what is called substantial equivalence, to prove that your GM crop is substantial equivalent to its traditional counterpart. I rather would call it a comparative safety assessment, because the way substantial equivalence has been used in the past is more the use as an endpoint of the assessment, while you should use it as the beginning of the assessment. Just try to compare scientifically identified differences and assess them. But that's a whole discussion which there's no time to do it. The framework is on characterize the genetically modified crop in terms of the properties of the organism and in terms of the process of genetic modification. And in terms of the environmental assessment, there are a number of parameters you should look at. And of course, one of the most important one is the identification of potential adverse effects on humans, animals, and the environment, and effects on dynamics of populations, genetic diversity, effects on non-target organisms. This is all described in details in this guidance document. For food and feed safety assessment, we have a very careful look at the characteristics of newly expressed substances, and we look very carefully at compositional analysis of the modified foods and compare it with its traditional foods. And we also look at eventual effects on food processing and nutritional modifications. So this is all spelled out. And I will not go into details, but the assessment of a GM crop in terms of its composition is very, very detailed. And I had this morning an interview, and they said, well, in fact, the GM crops are the best investigated crops ever if you look at the detailed analysis of the composition. This is normally not done with traditional foods, I must say. What about allergenicity, which is an issue which comes up all the time? And I think, although not particularly related to GM crops, we have to be careful in that area, because it is possible by using recombinant technology to transfer genes from sources which are not known as a food source. You could transfer a gene from an Antarctic fish into a strawberry and make it frost resistant. Now, this Antarctic fish probably is not a common food source, so we want to be sure that the proteins being transferred from alien species to our normal food crop do not bear the potential of allergenicity. So allergenicity, although not unique for GM crops, is an important issue. We have a strategy to assess it. I'm not going into details. The assessment of the different aspects are, I think, on its own, never 100% proof. You look at sequence homology. You look at whether the protein is stable or degrades easy. You look at the availability of sera of patients who may be allergic against certain sources. None of these issues is foolproof, 100% telling you whether the new protein is an allergen. But you should take all that information all together. That's what we call a weight of evidence approach. Sometimes very difficult to explain to laymen and to NGOs in that area, because we are always accused, yeah, but this is not foolproof, which is true. But if you look at all the evidence, you have a fairly good idea on whether you're dealing with a protein with allergenic potential. Now, this is an overview of what I've been telling you, and my message is there is a very detailed framework for food assessment of the introduced genes and of the newly expressed proteins and metabolites, and so on and so on. As I said, it's probably the category of the best foods ever investigated. Now, if you are interested, there was a European network program and a special volume on that, which describes into details the assessment criteria. Now, another issue, I have two issues I'd like to just to tackle, and then I'll come to my conclusions on public attitude. Now, one of the issues is what about what we call so-called unexpected or unintended effects due to genetic modification? That is an issue which comes on the table almost every week at EFSA. Which, of course, genetic modification may lead to unexpected changes in enzymes and metabolites and phenotype of a plant. Now, if this happens in the traditional breeding, then the breeder would discard off that plant and look at other lines which have been modified. There are good examples, there are a number of examples of unexpected or unintended effects in conventional breeding. In potatoes, for instance, they contain toxic glycoalkaloids, and it has happened that through breeding the content of these glycoalkaloids has increased and caused problems with human consumption. Celery, the famous example of some years ago in the US, where it turned out that celery just traditionally bred celery contained furanocoumarins, which are highly dermatoxic for people who touch these plants. But there is a very practical approach in conventional breeding, just by looking case by case at what could be changed in these plants and go after those changes. And I think we can learn in the genetic modification area a lot of the traditional breeding practices. Now, with respect to the detection of unintended effects, you could look at what I call a targeted approach. Go after compounds which could have been changed. But again, this is not giving you 100% assurance that nothing could have changed, because you do not have the methods for every compound which could possibly be changed. Now, there is a whole development now in the area of using what I would call profiling techniques. Instead of looking at one separate compound, you look at fingerprints of extracts of compounds. And you're trying to compare these fingerprints by using certain techniques like microarray analysis or proteomics or metabolomics. I'm not going into details. But these types of techniques provide for future work, they have a great potentiality. So looking at the level of the genome or the expression level of proteins, not looking at single compounds but at an overall picture. I think that is the future, not only for genetically modified products but also for conventional products. The other issue which is important is what about long-term effects of GM crops? Now, as I said, what do we know about long-term effects of any normal foods? Very, very little. As I said, systematic investigations of foods have never been done because we think there is no need to. And further on, if you look at your diet from today and compare it to the diet of what 5 or 10 years ago, there is a dramatic change in your diet over time, all the time in fact. So you never will be exposed to a certain food item all the time, every day of your life. So chronic testing of foods is questionable in terms of what happens in practice. The genetic variability, sensitivity of humans towards foods and foods ingredients varies a lot. So these types of experiments, for instance with humans, would be very difficult, if not impossible to perform. However, there may be indications through your genetic modification and the results of your molecular analysis that you would like to do some type of animal experiment, of testing, which could be predictive of long-term effects. And EFSA is now in the process of finishing a report in that area. You should go to the website and find this report. Now, our conclusion is that if the composition of the plant has been changed substantially compared to conventional foods, or if there are any indications for potential unexpected effects, then you may consider animal experiments. And I'm not going to tell you how difficult these experiments are. They are difficult, but they can be done. But you have to be careful. So we would not recommend this as a routine type of approach to assess the safety. Animal experiments are normally done between 3 and 6 months, and they turn out to be fairly predictive of long-term effects. That is the history we have from the scientific experience with chemicals, that these systems are fairly predictive. So my conclusions on the risk assessment framework is that there is a general consensus, international, on how to do it. There are differences. If you look at the regulations in the US or Canada or New Zealand, there are differences in terms of details. I think the European system is the most detailed one. The EU regulations, I think, have provided a transparent and adequate framework for the assessment. But has it helped to change the public opinion? That is the crucial question. I come back to that later. Separation between risk assessment and management in Europe is a good thing. But as I said, there are problems in terms of combinations and of communication. And what is important, that it's the Commission and the member states who are responsible for the decision-making process and not the scientists. Now, what about the public attitude on GMs? And this may be very different from the US. I'm not sure, but that's what I feel. Now, in Europe, we have almost a tradition now in measuring public attitude towards new technologies and or other problems related to foods and diets. That is called the Eurobarometer. And I'll show you some results of the latest one. I think that's the 6th one, which was held in 2000, the report was 2006, where they have been measured in each member state country, 1,000 respondents, and that gives you a fairly high reliability on the outcome of the results, by the way. And it turned out that if you look at the attitude of people towards new technologies, there is a great trust in information technology, solar energy, sustainable methods, wind energy, mobile phones, etc. There is a large optimistic view on the success of these technologies. Biotechnology is about half in terms of optimistic people. And I'll come back to this later, because if you look at the GM foods, that's much lower than this 52%. Nanotechnology and nuclear energy, especially nuclear energy, is fairly low in terms of optimistic rates of the public. Now, in terms of these technologies, in particular the biotechnology, there has been a decrease in optimism and trust of the general public over the years, but there is now an uprise, I would say, the last 6 years. And this is mainly on applications like new medicines, new vaccines made through recombinant technology. Stem cell research is highly estimated in Europe as a technology which really could contribute to well-being of humans. While GM foods, I come back to that later, is still low. Now, if you look at, in terms of risks, what is perceived as risk, and if you look, for instance, at gene therapy, that a certain risk is recognized by the public, which is the yellow bar. But there is even a bigger bar when it comes to the question, should it be encouraged? Yes, it should be encouraged, although people are aware of certain risks. But if you look at GM foods, there is a greater perception of risks in GM foods, while it absolutely should not be encouraged, the development of GM foods. So there is quite a bit of distinction within the public on the perception of these new technologies. Nanotechnology is I think, very positively perceived, like pharmacogenetics as well in Europe. Now, this is too much. This shows something on differences of opinions in European countries. And as I said, I mean, Europe is a mosaic of very different traditions and cultures. So no wonder that you would see a difference in attitudes. But on the overall, with respect to GM foods, it is something between 20 to at the maximum 35% in terms of support, depending on the country you're looking at. Now, one of the questions was, what are reasons to buy GM foods? If GM foods would be cheap, would you buy it? Or if GM foods have been positively assessed by the authorities, is that a reason for you to buy? And the answer is no. People would buy GM foods if they would be healthier, or if they would be better for the environment in terms of use of pesticides, less pesticides used, and therefore less residues. These are the main issues for the public. And therefore, I think if we talk on the GM technology, at least in Europe as a continent, then we should focus on applications which really could bring health and nutritional benefits. Now, this is an overview of differences in countries. For instance, Austria is a country which has the highest number of people who reject, for all reasons, GM foods, and Malta is with the lowest objections and the more reasons to buy GM foods. Well, the Netherlands is fairly low in the reaction. So it gives you a reflection of Europe in terms of attitude, which is interesting. And this is really food and feed for sociologists to look at this into more detail. Now, in general, as one can conclude that biotechnology is fairly positively received by the European people, but there is a strong opposition against agricultural biotechnologies. And GM foods, the development as they are now, they should not be encouraged. And the other important point is that I think unless we get new crops with pronounced properties which could be good for health or nutrition. So it may be very difficult to link the setup and the establishment of regulatory frameworks and how the public reacts. I'm not sure whether a direct link could be made. Maybe you know much more about it. But apparently, the setup of a framework in Europe to assess these crops has not had a great impact on public acceptance. And notably, the newer member states are not very supportive of the GM technology. And I guess, but again, this is guessing, this may have to do more with the fact that certain countries, they consider their environment, their biodiversity as being very specific and therefore needs their own protection, which in a way is true. I mean, you cannot compare the biodiversity system in Holland with the one in Slovenia or Hungary, which is true. But the issue here is whether GM crops would have detrimental effects on these various systems. And probably the answer is no. But the feeling here is probably sovereignty and the specific situation in a country. And yeah, the moratorium I was talking about in the 90s, that may have still have an impact on the public. Why was there a moratorium if there were no problems? The WTO. I mean, Europe has been brought as a WTO case recently, as you know, last year, which we lost. And there is a feeling that WTO should not interfere with so-called European businesses. Now, I think from a scientific point of view and economical point of view, this is an argument which probably you cannot hold. But the argument of other arguments to be taken into account, like social arguments, is a valid one. And I'm not sure whether the WTO is the right organization to do it. So it would be nice to discuss that at the next symposium on the function of the WTO. I think stigmatization of GM foods in Europe, that is the main cause. These foods have been labeled as Frankenstein foods. Now, before you get rid of that label, that will take some years and time. And I think that can only be demonstrated by foods, as I said, with specific health claims. However, I'm optimistic in the sense that GM foods, the situation have not changed very much, but it has not colored the opinion of the general public on other technologies in that area, like nanotechnology. Now, I would like to finish with the following thing. That is, if I looked at different risk analysis systems across the world, then there are differences, especially in terms of risk assessment and the connection with risk management. Now, there was recently a comment in Nature Biotechnology in July of this year by a good friend of mine, Evan McEwen. He is in California, Riverside. And he mentioned a number of flaws in the different regulatory systems. And it may be difficult to read for you. He asks a number of questions on, are we having an overemphasis on GM foods when it comes to safety? And my answer would be yes. At the other side, I think we could need a more balanced approach for our normal food supply. With other breeding technologies, you are able to change the composition of foods with all kinds of compounds of which we know very little. I mean, if I look at the advertisements in newspapers of big food companies 5 years ago on claims, on health claims, if you look at the progress in that area, still very little. As I said, there are no miracle compounds in this area. Alan makes another good point, and that is preferably you would like to compare risks in one food production sector with another one, like organic production and organic foods, and the risks of having contaminants in that area. The regulation does not allow it to do so. So this is an issue, I think, which needs more attention at the international level. And I'd like to finish with some ideas on a risk assessment, a risk analysis scheme, which takes more systematically different aspects into account. Now, I'm coordinator of a European-funded project called Safe Foods, and we look at the different main elements for the risk analysis. One is the framing phase of problems. What are the problems if it comes to GM or nanotechnology? Try to frame them and see who should act in that framing phase to provide the data. Then there is the risk-benefit assessment phase. So it's not only risk, but you should also look at benefits and try to come to some kind of balanced view on that. I think it's very important that in the risk assessment phase, there should also be a social and economical assessment of problems associated with new technologies of types of foods. So this should be an independent scientific assessment, natural science, but also social and economical impacts evaluation. Then there should be an evaluation phase for risk managers, where risk assessors and risk managers should sit together before decisions are made. So this is a circle, which in many cases is not a new one, but it tries to bring a more systematic approach in that area. And it would be very good if at a global level we could talk about these things in order to avoid very different risk analysis practices in different countries and continents, with all the negative impact on global developments and trade. And with this, I would like to thank you very much.
We'll open it up for a few questions.
Yes, yes.
And you can share the...
Okay.
Yeah, I have a couple of quick questions. By the definition of GMO, I can't understand it as a special category. That is, we know that agricultural crops trade genes with wild relatives in agroecological systems.
Yeah.
We know that modern plant breeding is not Gregor Mendel mating between plants. It's blowing apart genomes with irradiation or chemicals, creating new phenotypes. So the definition that you gave of mating, natural process, and so on doesn't, for me, define any different category at all. It's an incoherent category. Secondly, I have a question about the WTO findings. Basically, they argue that European science itself, the science done in Europe, does not support the policy of European governments, and therefore it is a protectionist restraint on trade rather than a science-driven policy. And I just want to know what you think about that. In this country, we deal all the time with science-driven distortions. I mean, you know, the Bush administration is one giant science distortion. And then finally, this question about regulation and protection. It's tremendously interesting. In the United States, the Centers for Disease Control say that 5,000 people a year die because our food system is under-regulated. That is, we have foodborne illnesses that kill 5,000 people a year. And yet there's an enormous amount of investment in time and energy worrying about things that so far as I can tell, have never killed anyone. So it's an interesting diversion.
You mean in terms of GMs?
Yeah.
Yeah.
I mean, I call transgenics because that's what they are. So GMO is a political category. I want you to try to define it as a biological category. To me, it's incoherent. And then this issue of where you put your regulatory dollar.
Yeah, well, in terms of definitions, I think you're right. There are some exemptions in the definition which I did not mention. The point of the definition is on the naturalness of the process, which is debatable, of course. It all depends on the distance and relation between species. The example I gave from fish to plants, it's in practice, well, it's not zero, but the chance is close to zero. There are a number of exemptions in the definition which I have not mentioned there. So you should go back to that directive to find out the details on the definition. Now, with respect to the science and the risk management, yeah, I agree that the WTO has pinpointed the Commission on its positions. Well, listen, the scientific assessment done in Europe is not very different from other parts of the world. So member states make up your decision, which is right. Now, the only thing I can think of that, apart from all kinds of political agendas, in certain areas, there may be some issues with respect to biodiversity. And to tell you the truth, I think that if Europe could take but this is my personal opinion, could take a more relaxed attitude in terms of cultivation, then we could save the import and export of products all over the world, from import from the US to Europe, etc. And if certain countries, the smaller countries in particular in Europe, like Austria and Romania or Greece, do not want to cultivate it, then I would say, well, that is then a local decision. But that should not block the whole system. Now, with respect to death related to food safety, I think that foodborne illnesses and hygiene in general are the most prominent causes of human illnesses and deaths. And although the scientific argument is GM food, is that a dangerous crop, you probably never resolve by just only epidemiological studies. You have no idea on exposure and times of exposure, etc., etc. I had a meeting at the Vatican 2 years ago, and that was presided by a cardinal. I'm not going to mention his name, but he said, well, I have been ambassador for the Vatican at the United Nations, and I've been eating this stuff for 10 years, and I feel fine. I mean, that's a very empirical approach in a way. It's an argument, but it's one of the arguments. So it can never be decisive, I would say. And if you look, for instance, in other areas like dioxin contamination, nobody has died from dioxins. Although we know these things you do not want to have in the food chain. Because if you look very carefully at these things, they are not recommendable in terms of toxic potency. Okay. Yes.
Can you talk about cross-contamination and cross-pollination? Because I have heard from organic farmers that are losing their business because of the cross-pollination, for example, on corn. And I also am concerned of what you said about how the scientists, the commission could make the decision even though scientists might say something else. So that's the second thing. And the third thing is there's no labeling in this country at all. I don't know what I'm eating. And I think that that's a serious problem because when we talk about organic food could be non-existent in the future with the cross-pollination and cross-contamination issue. Yeah. And also, Monsanto, for example, is suing people left and right and doing very criminal actions to small farmers or even larger farmers because of they're accusing them, well, you took the seed when the farmer didn't take the seed because the seed flew in from across the field. Yeah. So if you could speak on that, I'd appreciate it.
Yeah, well, it is a problem, coexistence of crops, conventional crops with genetically modified crops. And the Commission came with the ingenious idea that this should be solved at the national member states level. And in certain countries there are quite strict rules in terms of distances between crops, but in other countries not at all. So this is still an issue. But I think it can only be resolved at the national level. If you look at a country like Austria, with a very small-scale agriculture, you cannot compare it with France or other big countries. So you have to take the local situation into account. And well, this is easily said and written on paper, but it will take a lot of time. And the things you mentioned on organic farmers, yeah, we have the same rumors in the press. Not only rumors, I mean facts that in certain locations, their crops could be contaminated. Although in Europe, of course, it's still a limited problem, limited to France and Spain, where most of the GM crops are grown. But it is an issue, I agree. Now, you said you are worried about if the Commission would not take advice of scientists. Yeah, I would say yes, but on the other hand, it's very important that the Commission takes its responsibility. They may not like our advice, but they are the final decision makers in the whole process of risk analysis. And I have never seen in Europe a case where scientists would say, well, do not use this chemical or release a certain compounds. Well, the Commission would do it. But it could also go the other way around, of course. And, but a strict separation in responsibilities, I think, is very important. And to give you an example, I told this morning to Nick, I was in a committee, a European committee on the use of hormones for growth fattening purposes. And we had a question on the table, are these compounds safe? And our conclusion was, well, if you administer them properly and adequately, there is no health risk nor animal risk. And at the moment we wanted to edit that publication, that report, we were dismissed by the Commission because they didn't like the answer. And I had peace with that because that is a decision finally to be made by the Commission, whether you like it or not. And the other thing was, what did you say?
Oh, the labeling. Like, for example, if you go into
Yeah.
a store in the United States, there's
Yeah.
no labeling, you don't know what you're eating. And
Yeah.
I think that that's very important in terms of one's freedom.
Yeah, I agree. I only agree. Yeah. Yes.
Of course, the EU member states being quite generally very wealthy, whether or not the individuals are able to consume this current generation of GM crops really is relatively insignificant economic impacts. Of course, the situation is quite different for developing countries where, as you know, maybe 60 or 80% of household income may be needed for food. Yet, often the opposition of the EU member states to GM crops is used to support similar oppositions by developing countries where the consequences are much greater. My question, is this a concern, a consideration in Europe? Does this play at all the external implications of their internal decisions by wealthy nations?
I like your remark because I feel personally ashamed that the fairly negative attitude, how would you call it in Europe, is just spreading all over the world. I mean, I have some experience in Africa in that respect, in Zambia. If Europe thinks, well, this is not good, then why are we taking these stuffs from the US? I agree on you that this negative attitude spreading that's I think a very bad thing. I'm not aware whether the Commission is really taking care of that, maybe, but I'm out of those circles. But I recognize this as a fairly disastrous development because I have seen in South Africa how profitable the technology is for small farmers. That is, that is very impressive, I must say. Yeah. So, yes. Yeah.
Yeah, my question is on evidence and how much evidence is enough evidence, because you mentioned case by case, and I'm thinking now with the question that was just raised here, when do you reach a point where you have a consensus on a class of products that can be considered common shared knowledge transferable from situation to situation? When you go into developing countries, you want to think about responsible deployment. Who's going to do all that testing? It's unbelievably expensive. Who bears the cost of that? How much substantial equivalence can be used to supply the evidence needed inside other regulatory frameworks? Or are we always going to be stuck with the massive amount of data for every single product?
Yeah, it's a good question. I think the more experience we build up, some kind of streamlining and generalization must be possible. that may be, especially in the area of food safety assessment and nutritional assessment. For the environment, of course, you have to look at local conditions, and they differ quite a bit, country to country. But certainly for the food area, yes. And it's about time to think about it. So some kind of international orchestration in this area is needed. But who is going to take the lead in that area? I've talked to people from FAO and UNIDO to look in this area, to develop certain initiatives to tackle the issues you just mentioned. Yeah, it's about time to do it. And I'm sure that, for instance, herbicide tolerance could be taken as a class, or insect resistance, using some well-known proteins who provoke the insect resistance, and do a more generic approach instead of this case-by-case thing. Yeah, absolutely, I agree. Yeah.
Do you think with biofuels, will that change people's attitudes?
That is quite positively received up till now. Although looking at the market prices for normal foods, which go up quite dramatically already, that may turn into a negative attitude. If I look at the market price for corn, which have gone up quite a bit for farmers to buy feed nowadays. So I'm not sure whether on the long term, huh?
No, I mean in terms of GMOs. In terms of additives for GMOs, given that the profitability of using improved feedstocks for biofuels would make it, especially in developing countries.
Yeah, but as I said, I mean that is still quite positively received. But if normal feed prices go up because of scarcity, then that may turn around in terms of attitude. So I'm not sure whether this is sustainable in terms of public acceptance, yes or no. I'm not sure. Yeah, and then there was a question there. The lady first.
I was wondering if you could talk a little bit about the history of why GMO foods are so stigmatized in Europe as opposed to the United States.
Well, that's in fact that's a question to you. I mean, we in Europe we have some very effective NGOs, like Friends of the Earth and Greenpeace, to mention just two. There are more. They are highly well organized. They are very well funded, and they have a great credibility with politicians. And that may be different here. I think that if I look at the management of an organization like Greenpeace, and also attacking our opinions, they hire scientists, they pay them very well, much more than you ever would get if you just graduate from university. They're very well paid, and they tear our opinions apart, sentence word by word, and they're just looking for differences, not realizing that you should not only look for differences, but you should look at differences which may have a biological relevance. That's the issue, which is never touched by them. But I'm amazed by their efficacy in the European system, and I must say that if Greenpeace sends a letter to the Commission, to the Commissioner on, for instance, labeling of products from animals which have been fed with GM feed, then we have that paper next day on our desk to answer. So they are very effective, and I don't know about the situation in the States. At the other hand, the Eurobarometer has a more balanced approach of consumers. And therefore, although Greenpeace claims that 90% of the European consumers against GMOs, the European barometer shows lower figures. It's about 50-50. And in certain countries it's even positive. In country where I'm come from, the Netherlands, is a fairly positive attitude, Belgium as well. And there are a few more countries, while Greenpeace claims no, almost everybody's against. But yeah, it's a fact of life that they're very effective in campaigning, and they have the financial means. Yeah.
Most of the GM technology is not in public domain. It is with the private sector.
Yeah.
I was wondering if the universities or in the Europe, if the university contribute toward the development of transgenic plants, whether the acceptance can be enhanced or more credibility to the technology.
Yeah, could be, but I must say that the information in the dossiers, if NGOs want, they can get it. They just go to court and they get all the stuff. But I agree that, especially in the development phase, if universities could be more active, that certainly would help. I'm almost sure. I didn't mention it, but in the Eurobarometer there was also a question on trust. Whom do you trust? And universities are high in terms of trust. So yeah, that could help. But that needs money, of course.
Well, it's great to hear that universities are trusted. Thank you very much. There's a modest cookies and punch outside, but maybe we can continue the discussion.